Flatzoid's December Solstice Sunrise. Did Wally get it right? Let's play detective. Recently, Flatzoid had a live stream from his vacation spot in Margate, South Africa. And Where's Wally challenged him to take a picture of the sunrise, since his balcony had a great vantage point. Wally predicted a 118-degree azimuth of sunrise, along with a cartoon of the sun enjoying the surf. What does Flat Earth say? Let's start with a Gleason's map. Yes, I know that not everyone subscribes to this map, but it's the best one they have, since it describes a flat Earth, where the sun moves in a circle around the North Pole. Flat Earth folks and Globers agree on one thing, that on the date of the December solstice, the sun is directly above the Tropic of Capricorn. This means if we know the number of hours of sunshine, we can turn sunrise azimuth into a geometry problem. Let's turn to suncalc.org for sunrise and sunset times for Margate. Using my handy-dandy December Solstice spreadsheet, we first input the latitude, then give the times of sunrise and sunset. This gives us the number of minutes of sunshine and a percent. In this case, 59% of a 24-hour day in Margate will see the sun. Returning to the Gleason's map and knowing that the sun will complete a 360-degree circle above the Tropic of Capricorn in 24 hours, we can show the 59% of the day that South Africa will see the sun and plot the locations of the sun at sunrise and sunset. Let's star Margate, South Africa, and figure out the location of the sun at their sunrise, which works out to a 36-degree azimuth just by drawing on the map. My spreadsheet does all of that automatically and gives the prediction of a flat Earth sunrise azimuth of 36 degrees, well north of northeast. The spreadsheet comes from a video on solstice sunrise azimuths that I recorded 7 years ago, part of this playlist. Let's look at a globe-based analysis of the same problem, predicting azimuth of sunrise on the globe. The bottom right oval represents the apparent motion of the sun around the Earth on the December solstice. We can do a little trig, finding a value for x in this side view analysis. We then turn to a top view, where we complete the analysis using x, resulting in the azimuth of sunrise, shown by the yellow dot here. Returning to the spreadsheet, all we need for the globe analysis is the latitude, as seen on the previous slides. The spreadsheet does all the messy trigonometry for us, resulting in a prediction of 118-degree azimuth for sunrise for Margate, South Africa. This matches Wally's prediction from his video. But which matches reality, the globe prediction or the one using flat Earth geometry? Flatzoid published a follow-up video in response to Wally's challenge, where he takes us through a few smartphone screens showing us his latitude and longitude, and then shows us a video of the rising sun from his balcony. Can we put our detective hats on and figure out the truth? Let's start by entering in his latitude and longitude into Google Maps. I placed the little street view guy as close as I could to a due east heading from Flatzoid's balcony, and I got this view. I drew a line down the middle of the frame to indicate due east. Let's compare this to a frame taken from Flatzoid's earlier live stream. When we straighten it out, we can compare it to the street view photo. Take a look at the rise of trees and shrubs and the concrete driveway across the street. It's not a perfect fit, but it looks like the street view is maybe just a few feet from Flatzoid's view of due east. And there's another clue we can use in our analysis. This low building close to the beach. Here's a better view of it in his live stream, and here it is in his sunrise footage. Can we use this building to help us get an azimuth? If we look at the center of the lens flares, we can locate a spot on this building directly in our line of sight to the sun, marked with a pink X. Let's switch to satellite view and draw a line of sight from Flatzoid's balcony to the pink X. We can measure this azimuth using an angle measuring tool in Keynote, and we find a 111.5 degrees. Sorry, Wally, your prediction of 118 is just not good enough. Our detective work found it to be 111.5. But wait, This wasn't the moment of sunrise, was it? Well, let's return to SunCalc and manually change the time until we get an azimuth of 111.5 degrees for the sun. The time is 5:46, meaning that Flatzoid took his footage almost an hour after sunrise. Wait a minute, where did we see 5:46? That time sounds so familiar for some reason. Oh, I got it. Remember when Flatzoid was showing us some screens on his phone? 5:46 on the nose. So where is sunrise in Flatzoid's footage? Returning to SunCalc, we could find the angle of elevation, called altitude in the lingo, and azimuth for the two times in question, sunrise and Flatzoid's footage. If we do some simple trig with the values, we learn that sunrise made an angle of 59 degrees to the horizon, headed eastward. Here's our approximate location of sunrise. Not too far from Wally's cartoon sun, and his 118 azimuth was dead on accurate. Thanks to Flatzoid for the great footage, and nice job, Wally. Keep up the great work. Special thanks to my channel supporters, Johnny Ragadoo and Luke Filewalker. Rest in peace, Jim Jackson. And as always, please be kind to each other in the comments. Bye.